Hello, I'm Martin Ventura. I'm a master's student advised by Dr. Susan Paskowitz in the entomology department at UW-Madison. I'm thrilled to have this opportunity to share with you all about my research on farming insects. I'm honored to work within this planetary health framework where innovations which diminish the environmental damage caused by agriculture can be viewed both as directly and indirectly benefiting to human health. This rings true within practices of insect agriculture where many growers seek novel techniques to produce nutritious food while mitigating harm caused by intensive animal agriculture. You've probably heard some of the commonly cited environmental and efficiency rationales for farming insects. They're biodiverse, they're nutrient dense, they reproduce rapidly. Many commonly grown insects, such as crickets and yellow mealworms, require less feed, water, and land resources than traditional vertebrate livestock and are readily adaptable to urban, indoor, and vertical agricultural models. Insects can be grown at many scales and can be integrated into a wide variety of existing agricultural systems. Certain insects, such as our study species, the two-spotted cricket Gryllus bimaculatus, can be grown at artisanal scales by smallholder growers with very simple technology and minimal startup costs. In the communities in rural Zambia, with whom our research project is partnering, growing these crickets offers increased access to nutritious food and an important source of household income. My work on this project seeks to address a major constraint faced by our Zambian cricket farming partners, which is the prohibitively high cost of maize-based cricket feed. A commonly touted benefit of insect agriculture is the purported ability of many insects to thrive on agricultural byproducts or waste streams such as animal manure, food waste, and crop residues. My work investigates the feasibility of formulating cricket feeds from maize stover, the leftover stalks from corn production. In Zambia, stover is typically burned in fields following harvest, contributing to both greenhouse gas and particulate emissions. Corn stalks are a high-carbon, nutrient-poor feedstock. They contain lots of the complex biopolymer lignin, and straight out of the field, they are not good feed for crickets or other livestock. This brings us to the piece about the mushrooms. Edible oyster mushrooms in the genus Pleurotus absolutely relish lignin and will readily colonize maize stover, converting lignin into chitin, the major constituent of fungal cell walls. Pleurotus thrives on a wide variety of carbon-rich substrate, enzymatically digesting lignin and reducing the carbon-to-nitrogen ratio, which is an advantageous trait in cricket feed. This slide shows our own lab culture of Pleurotus on corn stover substrates, from harvest to initial establishment of mycelium to a mushroom fruiting event on the right. In the broader agricultural context of rural Zambia, farming mushrooms on crop residues holds the potential to benefit communities from a variety of economic and health standpoints. Mushrooms are a nutritious, prized, and culturally appropriate food in Zambia, and there's a growing interest in their cultivation. So at a primary level, growing mushrooms on corn stalks offers the potential to derive an additional saleable food crop from maize residues instead of burning them. In turn, once mushrooms have been harvested for human consumption, fungally cultured crop residues, still rich in chitin and fungal hyphae, may have potential for end use as a component in cricket feed. Excitingly, the cricket midgut contains enzymes which can digest fungal chitin, and Gryllus bimaculatus is known to consume fungi in the wild. We're eager to investigate a suite of variables related to the growth response of these crickets reared on maize stover that's been cultured with Pleurotus mycelium. Additionally, a central realm of inquiry for this project in direct connection with human health outcomes involves measuring the zinc and iron bioavailability in the tissues of these crickets reared on fungal diets. This micronutrition aspect of our investigation is important because these nutrients are commonly deficient in the diets of rural Zambians. Last, I leave you with this silly drawing that I did a couple of years ago depicting a hypothetical co-culture of insects with pastured poultry in a sort of tractor arrangement as a call to normalize insect agriculture. There are lots of reasons why the model depicted in this drawing might not be that great an idea. For one thing, it's a challenge to find a grasshopper like 3 times the size of a chicken. But I include it as a representation of the imperative for creative integration of farmed insects into existing agroecosystems. It's a reminder of the ways that the planetary health model calls on us to explore our strange thoughts and test non-intuitive synergies toward the benefits of our families, our biomes, and our planet. Thank you so much. Please feel free to contact me with any questions you may have about this presentation or about edible insects in general.